and my lecture will be the follow-up of the last year lecture about the exergy. And I will be talking about the stress with chemical storage. This means about the new exergy system which are in evolution. What this means, stress without stress? Stress is the short name about the sustainable, transactive, renewable exergy system, because I am in the principle, I think that we don't need energy. We need the exergy. The small amount of energy which is used by heat pumps and so on, in general, is available everywhere. But the exergy is not available everywhere. And we are fighting in the new world system for exergy and not only for energy. I will talk about these things because of the time. I will not go in the details, but in any way, we will be going through the three main topics. What is the present situation in society? We have the population growth, we have the environmental problem, and we have big use of natural resources. Second is the economy. We are still in the consumer society. We have large inequity in the world. And third, we are developing the new technology without chemical storage and so on and so on. But if we are going in these three questions, first I would like to show you some picture. First, society. We are talking living well within the limit of the planet, yes? But the population growth is going exponential. We need only 14 years to have a new 1 billion of new citizens. We need for this billion food, energy, apartments, and so on. This cannot go forever, because next year or 2 years after this will be 10 years for the new billion. Time is going on, and this vertical development should come to some problem. Second is the greenhouse emissions. 400 ppm we have just achieved, and we are fighting for 2 Kelvin of the heating of the atmosphere, but I think so it is not possible. But what is interesting, if we are looking on this biomass growth, we can see in the yearly oscillation decay for 6 ppm up and down. What does this mean? This means that we have some process on the earth which give us which take out from the air the CO2 and put in through the year. What is this? This is the biomass decay. And in my lecture, I would like to show you how we can use this biomass decay for the new exergy system. The next problem of the society is that we are now using 1.7 Earth. Footprint is clear, but this footprint is high because of the emission of CO2 gases. Who is making this overshoot? Not the countries in Africa or in India, but these are making the most developed world, Europe and United States. And if you are looking on the GDP per capita, you can see that we have in the world at the present the 1 to 350, and for the energy use we have the relation 1 to 150. How you can develop the society if you have no energy? Impossible. Energy is also the food. And the fourth, we have very uneven political, economical and social development. This is the main goal. Now is the difference is so big that the world is living in instability. And my question is, can we change this with the new energy system? And these four mega trends, I show you the forerider of the apocalypse, death, famine, and so on, is the question. But what is also, this picture was shown to you also, I think so, last year and 1 year before. I put always the new data from the United Nations about our development. And if I compare this development with the limit of the growth simulation in 72, the Club of Rome simulate business as usual development in the world 45 years ago. And you can see from this diagram, we don't teach anything. We are going directly to the catastrophe. This is not important, it's in 10 years, in 20 years, or 40 years. But we are not changing our behavior. What's more, society ethic is going down very fast on the world. And now, if we are looking on the technologies, we are developing excellent technologies. Everywhere is available, is cheap for some part of the world, and we have very good agriculture development. We have the road transportation, air transportation. Chemistry is developing new things, and we have a lot of problems with the plastics. Medicine and medicaments are also environmental unfriendly, and so on. Especially military equipment. They are not so environmental friendly as we mean. And of course, land use and city are growing very fast because of the growing global population. How we can stop these things, how we can stop the environmental degradation on the planet, where we have to start. My answer is, from 40 years ago, return to the sun. But with the sun we have some problem. Do we like such a country view in the future? I am sure nobody will be for this time. But we can change a little bit more if we are using something. Stress gives us possibility to develop the storage technologies. Professor Dr. Tabor in 75 in the Paris First Conference of Renewable Energy say, general use of renewable energy will be possible only if we find the chemical storage of solar energy. Only natural chemical storage of solar energy, exergy, is the biomass at the moment, including plants and animals. If we are integrated, if we will integrate the daily solar exergy with natural storage of solar exergy, biomass, then we will have the solution. Internet, industrial Internet of Things, and Internet of Things can make a very big role by developing this new system, because they helping us to overcome this daily and yearly oscillation. Why we are talking about the exergy versus energy? The last year I explained a little bit more about why exergy is important, why exergy is efficiency important, and why we have the problem with district heating. District heating is the low exergy heating using high exergy fuels. And how to change this is the main problem. And if we are using exergy as the measure of the resource depletion, we can evaluate quality of our processes, taking into account also the conservation of the mass, conservation of energy, and we include irreversibilities. Talking about the energy consumption is stupid. First law of thermodynamics, everybody knows, energy cannot be consumed. Energy can be transformed, but the exergy can be destroyed. Solar energy is pure exergy, so we have to use this in the way which is for long term acceptable for all population in the world. If the people is now talking about the circular economy. This is very modern, it's coming from Brussels. And what is the connection to exergy? Sustainable development means less exergy destruction or depletion in all circumstances. Circular economy is a policy to minimize the use of resources, to minimize the thermodynamics irreversibilities. This means to promote higher exergy efficiency over the life cycle of the system. We have many different indicators. I talked about this last year. Life cycle exergy analysis, exergy payback time, not energy payback time. We have the exergy payback time and exergy return on exergy invested. This is very popular also. Last year I showed you the pictures, and this one is the exergy balance for any production scheme. If the value of exergy return of investment is larger than 1, the system is sustainable. If it is less, then it's unsustainable. And you can see all the systems using the solar energy are sustainable without regard of the technology. And all systems using the fossil fuel are unsustainable. If we are talking about the sustainable transactive renewable exergy system, or STRESS, is transactive a new word. Why? I will explain you later. But the main problem is we would like to use solar hydrogen and biomass as the resource for chemical storage of solar energy. Also the batteries are the other type of chemical storage, but exergy is not in this moment included. Transactive. Why transactive? We are coming in the energy system, and energy system is in revolution in all the world. Never we have so big and fast transformation in energy system as is now. Transactive exergy system means that we have a network which allows communication between all points of supply and demand. We will have many thousands of suppliers of electricity, or for the heat, or for also other things. We have many thousands of consumers, and we have the trade relationship between them, and all these things has to go smoothly with stability. And of course we need in one point industrial Internet of Things, and the second we need in the Internet of Things for the normal population. What is the concept? Is the same as I showed you last year, but I will improve a little bit with the calculations. Sustainable transactive exergy system, as proposed, consists of the four main renewable exergy carriers. Renewable electricity, and from surplus we will make the hydrogen. Gas, this will be synthetic methane using the biomass and solar hydrogen. Liquid, that is the methanol, using the methanol made from biomass and solar hydrogen, and using the oxygen from the electrolysis of the water. Of course, we will have also the solid fuel from biomass in the transition period. These four renewable exergy carrier can be used forever in the earth without the emission of greenhouse gases. And what is important, with these 3 or 4 exergy carrier, we can use present infrastructure. We don't need to build a new infrastructure. Gas pipeline, district heating, electricity, everything can stay and can be used. Why methane and methanol? It is clear this is only chemical substances using 4 hydrogen with 1 carbon, and 1 carbon will come from the biomass, and we will use this as chemical storage in the future. We prevent the rotting and decaying of the biomass. I calculate for the Serbia and also for Slovenia, if we have enough biomass, to use the carbon in the biomass for the production of the same amount of exergy as we are using now. It is enough. It is much more than enough. This is only the question how we will be deciding. Stress is also an integral part of natural CO2 and the water cycle. We are coming from the from the low carbon society to the carbon recycling society, because we are, through radiation of the solar energy, recycling the CO2. What we have to replace? The job is not easy. At the present in the world, we have only about 10%, 12% of renewable energy. The rest, coal, gas and oil, has to be replaced. Do we have enough time? At the present, we have 33 years to the 2050, and we have to grow with renewable energy by 290 million ton oil equivalent per year. At the present, we are doing this very low, only 80 million ton of oil equivalent. This means we have to triple or quadruple the present change of energy use. Do we have enough resources? Absolutely. The present needed energy is 550 exajoule. Potential is 12,000 exajoule. In 2050, by the growing the population for 1 billion or 10 billion, we will need about 800 exajoule. This is only about 7% of the availability of solar energy. This is technical available, calculated by the IRENA in the REN 21. And now, do we have enough carbon on the world from the biomass to do this? Carbon stock on the world is about 500 billion tons of carbon. Yearly amount of carbon in growing biomass is about 100 billion ton per year. 50% is going in the sea, is produced in the sea, and 50% is produced on the land. The carbon we need for methane and methanol, I divide this in the 50-50, so half we will have the liquid fuel and half the gas fuel. For this we need yearly, at present use, 7,000 million or 7 billion. This is only 30% of the biomass growing each year on the earth. And if we are using only this part, the 87% of the biomass is staying as the wood or as the resource in the soil for food, for microbiota, which is necessary. Hydrogen production. The water is enough. We need the hydrogen for the conversion biomass to the new energy carrier for the total world. About 1.150 million ton, 1,500 is 1.1 billion ton. And if we use the water electrolysis, for hydrogen production we need electricity. And of course, this electricity can be provided by sun. About 64,000 terawatt per year we need, which give the power of the photovoltaic of 53,000 gigawatts. Expected installed PV in 2070 is 95 gigawatts. In total, world installed capacity is about 400 gigawatts. This is the big challenge, and we have to change our behavior, and we have to build the power photovoltaic and also the wind and the hydropower, but also the geothermal on the world. Oxygen is also plus by the electrolysis of the water, and there is no problem for the methanol production. And if I conclude, natural resources for the stress are in abundance and can fulfill our expectation. Where we stand with technologies, how long is the exergy payback time, and how big is the exergy return of exergy investment. Two new things are coming last month. In Singapore, the researchers has developed alternative ethylene production using solar energy. Here is the picture of the unit. This means we can use the photovoltaic, and from our power plant will come out ethylene, not methane. Teeny metallic gold particles showing in the research in Australia, they can convert sunlight directly to the fuel. Present technology payback time for exergy is a very low. For photovoltaic, maximum 1.4 year. For wind generator, less than half year. For small hydro, 1 year. And so on and so on. This means we have at present the technology which can be used to change our exergy system. What is important to know, you know everybody that Brasilia and some other country are developing their biofuels. I am not against the biofuels, but the total conversion from solar radiation to the ethanol in present technology, most modern technologies in Brasilia, is exergy efficiency of 0.002.5%. So if we, in 1 hectare, putting the photovoltaic, we have 40% efficiency and we have the electricity. Don't forget that the biomass has very low efficiency, exergy efficiency, with regard to the solar radiation, 0.2 or less. And therefore, we have not to calculate, not to plan our future energy development, energy carrier development, based on the using the biomass directly as for heat, as for production of electricity in the combined biomass heating power plant. We have to use this biomass, which is growing, for the conversion in the new fuels using the hydrogen, and to implement this for the better efficiency. My conclusion is the biomass should be used with high attention, using it for evaluation total exergy efficiency. Brussels winter package is completely without regard to this point. Everybody knows that Germany especially and some other countries would like to say diesel engine go away. Engine will go out and we will have only electricity, electrical car. But can you imagine how the heavy vehicles of 40 tons and tractors or passenger airplane Airbus can run on electricity with the batteries of the present or near future development? Never. But they can use gas, liquid gas. They can use the methanol for the power of the engines. Very easy and very simple, without any new complicated technology on it. In electric cars, we have two problems. They are more efficient, absolutely. But they are also the equipment which we have, or in each car we have our own electro power plant. And you are driving with the power plant everywhere, and you take the energy carrier from the outside on the station and so on. It's stupid. We have to have the system in which the power plant will be stable, not to carry 1.5 kilogram with us everywhere we go, up and down, but to use just the fuel, just the results of this. And I think so that the hybrid car are a solution for transition period, and calculating the present plans of introduction of the electric cars give us the results that we will have in 2030 11 million tons of battery for recycling. We make from one problem of environmental problem, other one. I don't know how this will be going, but the lithium battery recycling is not so easy. Fuels. In the proposed stress system, enable further use of internal combustion engines with high efficiency and zero emission. We don't need to change this perfect thermodynamic machine which we have now. The economy of such a system. In Energy Transition Outlook, the latest report of DNV-GL say the world will manage to shift to a renewable future without increasing overall annual energy expenditure, meaning that the future energy system will require a smaller share of GDP. And this is important for all countries in the world. Levelized cost of energy is going down. For photovoltaic, see, some years ago we have 7.7 cents for watt. Now we are selling the PV panel for 0.31. And the last announcement this morning, some Canadian company will make the new megawatt factory for the panels with concentrating solar energy with the cost of $0.2 per watt. This means it is a bright time before us. I will go to the conclusions. I think so the exergy efficiency is a good indicator for the exergy conversion processes. Proposed system can replace the present system with further development of chemistry for biomass conversion and in methane and methanol, and of course this new stress with renewable electricity will confirm the way to power to gas and power to liquid technology, which is our final goals. Thank you very much.
Thank you, Mr. Novak, for a nice and interesting presentation. Any question? Mr. Pachai.
Thank you for a very nice and very interesting presentation. I have a little bit philosophical question to you. You said that humanity has not changed much the last 40 years. It is a little bit like our students. They also prepare the papers they have to deliver the day before they have to do it. Do you think the humanity will start changing in due time, or do we run head on to the end where there is no recovery at the end, and then what? Or do we start now?
Look, I show you just the fact. 45 years, we have not changing anything. We are just rushing to the consumer society. And we know from which point, for which countries is this coming. I can only tell you, we have the time to change, if we would like. Somebody is talking about the smart cities, smart countries, smart energy system, smart electricity, and so on. Nobody tell us how we can achieve the smart politicians.